In this problem, we're considering a right triangle. I've got it drawn already off to the right, and we've got the curve y equals e to the negative x over 3. And important to note is that we are limited the x values between 1 and 5. And we are asked about the maximum and minimum areas for this triangle. So let's first take a look at a picture of what we're dealing with here. So here's a picture of that right triangle, and we can see how the area would change as we go from 1 to 5. And we're only going to go from 1 through 5. And remember, when you have endpoints, your max or min can happen there or at a critical number. So perhaps there's a critical number in the middle here. That might be that maximum, and we've got little areas on either end. But we're not sure from looking at this which one is going to have that minimum area. All right, so here we go. Let's get set up. The first step after we understand the problem always is to make sure we realize what we're trying to maximize or minimize. So in this problem, we are asked to find the maximum and minimum area. So let me just circle that so we remember what we're doing. Once we identify what we're doing, we want to write a formula for that. But before we do, I want us to remember that maximums and minimums occur at critical numbers or endpoints. And since this one has both and endpoints, we're going to have to consider all of those. All right, let's start off with our formula for area. We have a triangle, so it makes sense to do the formula we all know, 1/2 base times height. But we look at this and we've got too many variables, and it doesn't really have anything specific about our situation. So in our situation, this particular triangle has a point right here at x, e to the negative x over 3. That x coordinate is the same as our base here, because when I go over x to this, that is the base of my triangle. And when I go up y here, which is my height, it's going to equal that y coordinate e to the negative x over 3. All right, so I'm going to put those in over here. So area equals 1/2, base is x, and my height is e to the negative x over 3. All right, so to find critical numbers, we need a derivative. So let's find our derivative, dA dx. I look at this and I see I have two functions, which means I need product rule. I'm going to leave this 1/2 out front, that constant, which isn't going to change anything. So I have x left alone, and the derivative of this is e to the negative x over 3 times the derivative of the inside, which is negative 1/3, plus the derivative of x is 1, and e to the negative x over 3 left alone. Now to find critical numbers, I need my derivative equal to 0, and this right now looks like a big mess, but I do notice that there is an e to the negative x over 3 in both, so I'm going to factor that out. So I have 1/2 e to the negative x over 3, and then I'm left with negative 1/3 x plus 1. And now I can find my critical numbers. 1/2 is always 1/2. This is always positive, so I'm never going to find a critical number there. You can even see from the graph, remember, it's always positive. And here, I can just look at it and say, oh, I know what's going to make that 0. X equals 3. Now, if you weren't able to do that so fast, go ahead and just set that whole thing equal to 0 and solve the equation. And you will, in no time, realize, oh yeah, I'm going to get 3. All right, so we found our critical number. And remember, our maximum and minimum occur at critical numbers or endpoints. So, and we're supposed to actually find those areas. So it asks for the areas. So just to save us some time, I already did that calculations. Desmos was really helpful here. This is that formula we have for area. So here is that formula rewritten there, and here are my x values. There's an endpoint, critical number, another endpoint, and we see these numbers here, and you'll notice there's my largest one. So there's my max area, and my smallest one is right here. So there is my minimum area, and I have finished this problem.